Hello everyone! This is the first of a couple of short videos about Neuron, EVS's network-attached real-time IP and SDI media processor. The 1RU high Neuron frames can be equipped with two reprogrammable processing boards. What kind of processing each board can do depends on the software loaded on these cards, which comes in many different flavors. The software variations can be divided into various identities, such as Bridge for bridging SDI to and from IP, Convert for miscellaneous audio and video processing, like for instance format and HDR conversion, Protect for firewall and auto failover applications, Compress for high quality low latency compression of HD and UHD signals, Shuffle for swapping and shuffling thousands of individual audio channels, and View, our Neuron-based live production multiviewer. On our website, on the Neuron product page, there is detailed information about each of these categories in the product datasheets. We will go over each category of cards one by one in the following Neuron shorts. But first, let's go back a few years to understand where Neuron comes from and why it is such an essential product in modern broadcast environments. Not so long ago, before the IP revolution, everything in a studio or OB facility was SDI based, using coaxial, or in some cases fiber, cables to connect all inputs and outputs of all your video and audio devices. These cables can traditionally only carry one signal into one direction. So if you have a device which requires 16 channels in and 4 channels out, you have to physically connect 20 cables. If the outputs of this device have to go to 8 different other devices, you have to connect the outputs to a DA or to a router and multiply each signal to 8 physical wires, so 32 additional cables. The evolution from SD to HD and later UHD resolution also contributed to an ever-increasing amount of copper wires inside a broadcast facility. A single UHD signal often requires 4 wires to be carried from one device to another. So the number of cables grew exponentially when studios and OBs grew bigger and bigger and required higher resolutions and frame rates. Professional cabling companies obviously thrived during this SDI peak, creating these kinds of, admittedly sometimes very satisfying looking, installations of insanely big bundles of cables. You can imagine of course that cables and cabling services were at one point responsible for a big chunk, if not the biggest chunk, of the total investment in a new broadcast facility. Enter baseband live media over IP. It took our industry a few years to standardize to a certain encapsulation standard, but once everyone settled for the ST2022 and ST2110 standards, manufacturers and broadcasters around the world embraced the new technology to allow much higher bandwidths, multi-signal carrying and bidirectional traffic over a single cable. And not only the benefit of being able to go from this amount of B and C cables through this single directly attached copper cable to transfer 32 channels of full HD video drove the demand for IP infrastructures. Also, the more efficient ways of distributing your streams through multicasts, being able to subscribe to any stream on the network simply by connecting to a certain IP address without the need for DAs, and the possibility to have a more distributed topology drove the IP revolution in the broadcast industry to where we are now. Going back to the previous example, if the device is upgraded with IP, you can throw out all coax cables and distribution devices and simply connect it to a network switch using only one cable. So nowadays we have these 100 GB per second Ethernet cables in our equipment rooms, carrying dozens of signals. 32 video channels over 100 gigs per second or 5000 audio channels over 10 gigs per second is not exceptional. This also means that media processing equipment suddenly has to be able to process multiple channels at the same time in a single device. Where with Synapse, for instance, you insert one module to process 1 or 2 signals, you now need a device which can take in these 32 channels over one cable and process them all at once. Because multiplying that 100 gig connection 32 times to connect to 32 different modules of course reverts the cabling advantage we just created. This explains why Neuron was developed and why it is different from the one module per signal approach you see in glue equipment like Synapse. We use our 30+ years of experience in FPGA programming and PCB design to develop a generic platform with the equivalent performance of 16 Synapse modules combined on one board with massive processing power and with 100 gig I/O. Which functionality is enabled on each board is defined by the software, so uploading a different firmware file to a processing board can completely change the processing abilities of this board without exchanging or adding any hardware. This ensures unmatched flexibility, so that when your requirements change, the functionality of your various Neuron boards can change as well to meet these new demands. One Neuron board has the capacity to process up to 32 Full HD signals, which is equal to 8 UHD signals. And as I explained at the start of this video, a Neuron frame can contain 2 of these boards, providing the power to process up to 64 channels in real time on only one RU. Rack space wise, cabling wise and power consumption wise, this is a huge advantage compared to modular SDI processing, which would require at least 64 coax cables, much more electrical power and at least 8 RU of rack space to do the same. And even if you still have SDI equipment that needs to be integrated in your workflows, Neuron can optionally be equipped with SDI expansion boards, allowing 40 physical HDBNC connections per processing board, resulting in 80 SDI connections per 1 RU. These SDI connections can be used to go from SDI to IP or from IP to SDI, making it fully flexible for IP-only environments as well as for SDI and IP hybrid media infrastructures. Neuron also benefits from other IP technology advantages. You can configure the IP inputs to receive any stream available on the network simply by changing the IP address of the listener. You don't have to physically rewire your setup or change router crosspoints to have Neuron process different channels. As long as you are connected to the media network with the high bandwidth Ethernet cable, you are connected to all your media streams. That's why we call it a network attached processor, or NAP in short. And everyone does still need real-time processing in the IP domain. We're still dealing with baseband video and audio. The actual video and audio formats didn't change, only the way the signals are packetized and carried is now different. You still need to synchronize the frames of all your streams so that each frame of each signal starts at the exact same time. You still need to sometimes up-down cross-convert your video from time to time. You still need color correctors. You still need HDR converters, embedders, de-embedders, audio shufflers, etc. So having a device attached to your network, which can do IP and SDI media processing in real time, is a base requirement for every broadcaster working with IP infrastructures. That's it for Neuron Short number 1. In the next video we're going over the basic architecture of a processing board and the general structure of the neural control interface in Cerebrum. So see you soon!